Hello, today we're doing lesson 4.6. We're going to discuss complex numbers. Not all quadratic equations have real number solutions. That's what we did yesterday. We were getting real number solutions. For example, x squared equals -1 has no real number solution because the square of any real number x is never a negative number. To solve this problem, mathematicians created an expanded system of numbers using the imaginary unit I. As it is defined as I equals the square root of -1. So this is very important. You need to know this. This I is the square root of -1, and I squared equals -1. If r is a positive real number, then the square root of -r equals I root r. By the first property, it follows that if I were to square I root r, you would square I, which would be I squared, and you would square root r, which is r. I squared is -1, so -1 times r is -r. And you'll see what I'm talking about as we go ahead and start these problems. So we're going to solve the equations just like we ended yesterday's lesson. We are going to get the squared term by itself. We're going to root both sides and get an answer. So number 1, this is a simple one. X squared is already by itself. We're going to square root both sides. Now, I have x. I have plus or minus. Because there's a negative underneath the root, we pull that out as an I, and the square root of 100 is 10. So my answer is plus or minus 10i. Okay, let's try another one. We're going to add 8 to both sides. I get x squared equals -28. I square root both sides. So I have a plus or minus. I have an I because I'm taking the negative out from the root. If I reduce the square root of 28, when you go ahead and make a factor tree for it, you end up with 4 root 7. So I'm going to write it as plus or minus 4i square root of 7. See how I wrote the answer? Okay, pay attention to that. Make sure you write it like that every single time. So this problem, we're going to go ahead and add 7 to both sides. We get 3x squared equals -24. Divide both sides by 3. We get x squared equals -8. We square root both sides. We get x equals plus or minus 2i root 2. Now where did I get these numbers from? I have the I because of the negative underneath the root. If I make a factor tree for the square root of 8, I would get 2 root 2. That's my answer. Now I would like you to take a minute to pause the video and try the you try on your own. Okay, welcome back. Just so you understand how complex numbers work. Basically, a complex number is written in standard form is a number a plus bi, where a and b are real numbers. The number a is the real part of the complex number, and the number b is the imaginary part of the number. So let's take a look at this system. Basically, we have two forms of numbers. We have real numbers, that's what you're used to dealing with, and we have imaginary numbers. So inside imaginary numbers, we have what we call complex numbers. Complex numbers are when there's a real part and an imaginary part. Okay, so it kind of gives you an idea of how the number system works in math. So basically we're going to focus on when there's a real part and an imaginary part. We're going to write the real part first because that would be standard form. So our numbers are going to look like this. Okay, let's go ahead and try some problems so you can see an example of what I'm talking about. All right, sum and difference. Sum and difference just are adding the real parts and adding the imaginary parts, or subtracting the real parts and subtracting the imaginary parts. So what you need to be careful of is anytime we're subtracting, because it is like you are going to distribute a negative. So leave this first part alone, 7 minus 6i, and then distribute the negative, so -3, and distribute this becomes plus 6i. Now, you want to write your real parts first. So 7 minus 3 is 4, and then -6i plus 6i is 0. You don't need to write 0i, so our answer to this problem is just 4. Okay, let's go ahead, distribute this part just inside the parentheses, so 10 minus 6 minus 7i plus 4i. So 10 minus 6 is 4, -7i plus 4i is -3i. And this is how I want to see the answer, the real and the imaginary. This would be considered standard form. Go ahead, pause the video, and try the next you try on your own. Okay, now we're going to talk about multiplying complex numbers. Basically what you have to remember is this. If you ever end up with an I squared, you have to look at it like -1. All right, we'll go ahead and get started with the examples. Here I'm just going to distribute. So when you're multiplying, think of the I as an x. Do the same thing you would if that were an x. So 4i times negative 6 is negative 24i. 4i times I is 4i squared. Now this is where we need to do something different. So because this is an I squared, think of it as negative 1. So 4 times negative 1 is negative 4. Now I want you to rewrite this so the real number is first. So negative 4 minus 24i. This is my answer. Okay, let's go ahead and try another problem. Now be careful. See the negative? We're going to leave that alone for a minute. We're going to go ahead and FOIL this out. So 3 times 5, 3 times negative 2i, I times 5, and I times negative 2i. Okay, then I'm going to add up my like terms. So we have 15, well, let's fix this. I squared is negative 1. Negative 2 times negative 1. This becomes a plus 2. So 15 plus 2 is 17. Negative 6i plus 5i is negative I. Now I'm going to distribute the negative. So negative 17 plus I. That's it. You can leave your answer like that. I have the real and then I have the imaginary part. Go ahead, pause the video, and try this next problem on your own. Okay, welcome back. Now, i's are the same thing as square roots. We cannot leave an I in the denominator. So sometimes you just multiply by I, and sometimes you're going to need to multiply by the conjugate. We're going to multiply by the conjugate when there's a plus or minus in the denominator with an I. So let's just get started. Number one is simple because there's only an I in the denominator. So we're going to multiply the numerator and denominator by I. So the top, I get 3i, and the bottom, I get I squared. Now what is I squared? Negative 1. So what's 3i over negative 1? That's just negative 3i. Now, next problem. Here we need to multiply by the conjugate. We need to multiply by 3 minus I, 3 minus I. So on the top, we're going to distribute. 2 times 3 is 6. 2 times negative I is negative 2i. Now in the denominator, this is just like what we did yesterday. We're going to FOIL, but we don't need our middle terms. The whole point of multiplying by a conjugate is so those middle terms cancel out. So 3 times 3 is 9. 3 times negative I is negative 3i. I times 3 is 3i. So the negative 3i and the 3i cancel out. So that's why I'm not writing it down. I'm just going to do the first terms and the last terms. I times negative I is negative I squared. So remember, I squared is negative 1, but there's already a negative here. So it becomes plus 1. So I have 6 minus 2i over 10. Now, I do want you to write it as real and imaginary. And if you notice, we can take a 2 out of the 6, the 2, and the 10. So when I do that, I end up with 3/5 minus 1/5 I. So I just wrote it separately. I wrote the 3 over the 5 and the I over the 5. This is how you write it in standard form, the real and the imaginary part. Okay, let's go ahead and try this next one. Now this is about as messy as it gets because you're going to notice we have to also FOIL on the top. So we're going to multiply by 3 plus 2i and then 3 plus 2i. So the top is going to be messy. We're going to FOIL it out. So we get 15, 10i, 6i, 4i squared. This becomes a negative 4 because it's 4 times negative 1. Then on the bottom, we're just going to multiply the first terms and the last terms. Okay, now we're going to go ahead and add our like terms. So on the top, we're going to get 11 because I'm doing 15 minus 4 plus 16i. And then on the bottom, we get 13. Now, technically this is correct, but it's not in standard form, so we're going to write it as 11/13 plus 16/13i. We want the real part and then the imaginary. So go ahead, pause this video, try the last you try on your own. If you have any questions, comments, or concerns, go ahead, write it at the bottom of the paper, and I'll see you tomorrow.